Hello everyone. So this was the last question which we discussed in the previous video, right? So again, we are going to discuss the last part of this series of complex numbers revision. So let's move to the next question here. If you have not seen the previous videos, please watch those videos, okay? So the next question is, if a complex number Z1, Z2, Z3 are the vertices of equal triangle and Z not be the circumcenter of the triangle, then prove that Z1 square plus Z2 square plus Z3 square is equal to 3 Z naught square. Okay. So now it is given that Z1, Z2, Z3 are the vertices of an equal triangle. So let's say this is the triangle we have. This is vertex Z1, this is vertex Z2, and this is vertex Z3. So these are the three vertices of equal triangle. That means all the three are equal, right? Now, before solving this, you must remember one result for any equal triangle. If you have Z1, Z2, Z3 vertices, then always remember this result. This is Z1 square plus Z2 square plus Z3 square. This is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. Very important result. This can be very easily proved by using either the rotation theorem, or you can check, we can apply these three lines have the same length, right? These three sides have the same length. We can use that also. By that you can easily prove this. Only for equal triangle. This is for equilateral triangle. Only for equal triangle we have. Very important results. Many questions we will find on the same concept. Okay. Now it is given that Z naught is the circumcenter of this triangle. Now see, Z naught is the circumcenter of this triangle. But if this is an equal triangle, we know the circumcenter, orthocenter, incenter, centroid, all will be at the same point. All these will be at the same point for equal triangle. So can we say Z naught is circumcenter? This is also the center of the triangle. Now, if Z naught is the center of triangle, I can say this is Z1 plus Z2 plus Z3 divided by 3. Centroid coordinate Z1 plus Z2 plus Z3 by 3. This is centroid, and this we have equated to the coordinate of circumcenter because ultimately both are same point for an equal triangle. Now we have to just manipulate this to get this result. So how can you manipulate this? You can just square on both sides. This is 9 Z naught square. This is Z1 square, Z2 square, Z3 square plus 2 Z1 Z2 plus Z2 Z3 plus Z3 Z1. We have this relation, correct? Just squaring on both sides. Now we know that Z1 plus Z1 Z2 plus Z2 Z3 plus Z3 Z1 is equal to this quantity. I can substitute here. This will become 9 Z naught square. If I put this quantity here, you can see this is Z1 square plus Z2 square plus Z3 square. So this will become 3 times Z1 square, Z2 square, and plus Z3 square. So this is, you can see 3 Z naught square is equal to Z1 square, Z2 square plus Z3 square. This is what he had to prove. So the important thing is this condition and this, you should know that centroid, circumcenter, incenter, all these are the same point for the equal triangle. So, okay. So I hope this is clear. Now let's move to the next question. The minimum value of a plus b omega plus c omega square modulus, where a, b, c are all not equal integers. They are integers, but not all are equal. And omega is a cube root of unity, which is not equal to 1. Right? What are cube roots of unity? 1 raised to 1 by 3. This is 1 omega square. So we are saying 1 raised to 1 by 3 cube root of unity is here omega, which is not equal to 1, right? Standard. You know what is omega, right? Now the question is, you have to find the minimum value of this expression, a plus b omega plus c omega square modulus. Now see, if you have a plus b omega plus c omega square modulus, I want to manipulate this. I want to find the minimum value of this. Now, how can you minimize this? For that, you have to simplify this. So how can you simplify this? I can say this is square. Let's say if I take this square, then we know what is modulus of a complex number. This is c omega square. What is mod z square. This is z bar. So you can say this is z and its conjugate a b omega conjugate c omega square conjugate. Correct? A, B, C are some real numbers because they are integer. That means they are real numbers. So now you see this is a b omega c omega square. This is a plus. This is b omega bar. Now understand this. We know omega bar is equal to omega square. Omega bar is equal to omega square. So omega bar square will be equal to omega raised to 4. And you can see omega raised to 4 is equal to omega because omega cube is equal to 1. So that is effectively omega. So I can write this is plus this is c omega, sorry, c omega, right? Omega bar square, this we have replaced with omega. And in fact, we can replace this also. I can say, just wait. I can just write this omega bar as omega square. I can just replace this omega bar as omega square. So this is simplified. Now I can just multiply. If I just multiply this, you will have a square plus, you can see this is b omega square. This will become b square omega cube. Omega cube is equal to 1. So this is b square plus c square. You can see this is again c square omega cube. Plus you will find ab. A into b omega square, a into b omega. So this will become omega plus omega square. Similarly, you will find, you can see ac, the b c omega square plus, you can see this is b c omega raised to 4. Omega raised to 4 is same as omega. I'm just multiplying this bracket, okay? Plus you will have AC. Now how will you get AC? A into C omega plus this is, you can see AC omega square. So this is, I have taken common. Now you see, we know omega plus omega square. We know the property that 1 plus omega square is equal to 0. Sum of cube roots of unity is 0. So you can see this is a square plus b square plus c square minus AB minus BC minus CA. Now we have got an expression. Now we have to find the minimum value of this. Minimum value of this expression. Then we have to take the square root, right? Now this is again a standard notation, standard result. How can you factorize this? I can say this is equal to 1 by 2. A minus B omega square plus B minus C omega, A minus B square plus B minus C square plus C minus A square. You can write this. And this is again very important. If you don't know this, you have to just remember this. Very important result, right? You can just simplify this and check, you will find this. Okay. Now see, it is given in the question that A, B, C are integers. A, B, C are some integers and they are not equal. They are not all equal. They are not all equal. If you have to find the minimum value of this, can we say the minimum value will be when two numbers will be equal, let's say A and B are equal, and the third number will be just plus 1. You can see, let's say A and B are equal, and C will become B plus 1 or A plus 1. Why? Because you can see the difference will be minimum when the numbers will be consecutive. Correct? So you can see what is the minimum possible value. I can write this minimum possible value will be 1 by 2. Let's say A and B are equal. If A and B are equal, this will become 0. This will become 0. What is B minus C? This will become plus 1. This is 1. Plus this is also equal to 1 because ultimately A and C are, A and B are equal. So this is also equal to 1. So this is the minimum possible value. So what is the minimum possible value? You can say A plus B omega plus C omega square modulus minimum. This is equal to 1. Square root if I take, this is equal to 1. So now what is the minimum possible value of this expression? This is equal to 1. This is again, this has been repeated twice in IIT JEE also, the similar type of question. Okay. So you can expect this kind of question in JEE Advanced, JEE Mains also, right? Now let's move to the next question. Now, Z1, Z2 are the nth roots of unity. Nth roots of unity which subtend a right angle at origin. Then n must be of the form. Okay, now see, Z1, Z2 are nth roots of unity which subtend right angle at origin. Now, if you just remember, if you take any complex nth root of unity, this is 1 raised to 1 by n, right? So what are the values of nth roots of unity? This is, you can say 1 alpha, alpha square, so on, alpha raised to n minus 1, where alpha, let's write it here, where alpha is equal to e raised to iota 2 pi by n. This is how you write the nth root of unity. If you write, let's say, third root of unity, so what are the third root of unity? 1 alpha, alpha square, where n is equal to 3. So this is e raised to iota 2 pi by 3, 1 omega, omega square, right? So this is the nth root of unity. Now, you first understand there are some very important properties of nth roots of unity. So if I draw a unit circle, let's say this is the unit circle, radius is equal to 1. All these nth roots of unity will lie on a circle of radius equal to 1 because all these have the magnitude 1. All these complex numbers you can see will have magnitude 1. So this is the first nth root of unity. Let's say this is 1. This is the second nth root of unity. Let's say this is alpha. This is the third nth root of unity, alpha square, and so on. They are symmetrically placed. I'm just randomly drawing this. Let's say this is the last nth root of unity, alpha raised to n minus 1. And then we have this, right? Now, if I join them, you can see if I join them, this is the property which you must have done. All these will be equal. Why all these will be equal? You can see here. If I join this, what is this alpha? Alpha is e raised to iota 2 pi by n. So this angle will be 2 pi by n. Similarly, this is alpha square. If I join this, total angle, this is e alpha square, e raised to iota 4 pi by n. So this angle is equal to 2 pi by n again. That means all these are subtending same angle. These sides are subtending same angle, 2 pi by n at the center. Correct? So all these nth roots of unity are vertices of a regular polygon, n-sided regular polygon, and they are subtending equal angle at the center of this circle. Now the question is, Z1, Z2 are nth root of unity. You can take any two nth root of unity. Then the angles which subtend a right angle at origin. So for example, if I take, this is the first complex number, Z1. Z1, I don't know which is Z1. Okay. Now this is Z2. This is the second, this is the another nth root of unity. I can take one of them as Z1, another as Z2. Now, what is the angle subtended by this at the center? You can see here, if I take this, what is the angle subtended by them? This is 4 pi by n. 4 pi by n, correct? And it is given that this is equal to pi by 2. Subtended at origin, this is equal to pi by 2, right? So what is the question? N must be. So what is n? N, you can see this is equal to 2. N is equal to 8. N is equal to 8. Right? This is 4 pi by n, and this is subtended is pi by 2. So this is equal to 8. Now, let's say this is Z1 and this is, let's say, Z2. So what is the angle subtended here? This angle subtended will become what? You can see this is 6 pi by n. 6 pi by n. So this is equal to what? This is equal to pi by 2. So what is this? This is n is equal to 12. Correct? So what can we say here? All these numbers, 8, 12, let's say if I take, this is another complex number. This is angle. What is angle subtended by this? Now this will become, so can we say all these numbers, if I take any two complex numbers, they will subtend some angle of the form some lambda 2 pi by n, some multiple of 2 pi by n. And this, it is given that this is equal to pi by 2. So what is n? N should be equal to 4 lambda. N will always be multiple of 4. Because it is not given in the question that they are consecutive. So they can be, let's say this is Z1, this is Z2. It may be possible that this is Z1 and this is Z2. I can have any number, right? So this is n should be equal to 4 lambda, right? So what is the answer? The number n should be of the form 4k. It should be multiple of 4, right? So that is the question which we have. Again, few one properties here, nth roots of unity always lie on a circle of unit radius, and the angle subtended by each side of this, okay, a regular polygon, 2 pi by n, right? So we have just used that property here. Now let's move to the next question. Okay, now this is again a simple question again, but this is very common question and you have to understand the concept behind it. See, in the question it is not mentioned that what is we have to find the value of this expression, but it is not mentioned that this question is related to cube root of unity. But if you just understand this, we know cube roots of unity are 1 omega omega square, 1 minus 1 plus minus root 3 iota upon 2. These are the cube roots of unity. So what is omega? Omega is minus 1 plus root 3 iota divided by 2. Assuming omega is equal to minus 1 plus root 3 iota upon 2. So this expression, basically this expression minus 1 by 2 plus iota root 3 by 2. This is omega. So if you have to simplify this, you can use the properties. This is 5. And what is this value? This is omega raised to 334. And this is 3 omega raised to 365. Right? So if you have this type of expression where we have minus 1 plus root 3 iota upon 2, minus 1 minus root 3 iota upon 2. So always you can use the concept of cube roots of unity. Now you see, this is 4 plus this, I can say this is omega 333 into omega, multiple of 3. I'm just making multiple of 3. And this is 3 omega 36. I can say 3 omega square. I hope this is clear. 363 is a multiple of 3 omega. So this will become 1. This will become 1. So what is this value? This is 4 plus 5 omega 3 omega square. Now, how can you further simplify this? We know 1 plus omega square is equal to 0. All right. So if I just substitute this, you can see here, I can write this is 3 plus 3 omega plus 3 omega square plus 1 plus 2 omega. Correct? I can, what I have done is I have just taken this 4, 3 plus 1. You can see 5 omega, I have written it 3 plus 2 omega, and this is 3 omega square. And now this value is equal to 0. So what is this value? This is equal to 1 plus 2 omega. What is omega? Minus 1 plus root 3 iota divided by. So I can just cancel this. This is minus 1 and minus 1 will cancel. So you will have root 3 iota. So what is this expression? This expression is equal to iota root 3. So I hope this is clear. It's a very easy question, just based on the simple concept of the cube root of unity. Now, the next question here, you can see here, if you have, we have to find the value of this expression. This is k is equal to 1 to 6 sine 2 k pi by 7 minus iota 2k pi by 7. What is this value? You have to find, where k is equal to 1 to 6. Now, you can solve this question without complex numbers also by using simple trigonometry, or you can use the concept of complex number. I'll give you both the methods. First, you understand, let's say, if you don't understand the, if you don't find it difficult, if you find difficult by using complex number, then you can use trigonometry. How can you use trigonometry? You can see here, I can write this series as sigma k equal to 1 to 6, k equal to 1 to 6, sine 2k pi by 7 minus iota. This is k is equal to 1 to 6 cos 2k pi by 7. We have this. Now see here, if I just open this, you can see first bracket, this is sine. If I put k is equal to 1, 2 pi by 7, then sine 4 pi by 7, so on, plus sine, you will have 12 pi by 7. You can see minus iota. If I put k is equal to 1, this is cos 2 pi by 7 plus cos 4 pi by 7 and so on. This is plus cos 12 pi by 7. This is the expression we have, right? Now, I hope you have done this kind of series. If you have, let's say, sine A plus sine A plus D and so on till n terms. That is, if the numbers are, the angles are in AP, the angles of this series are in AP, then what is the sum of this series? This is sine n into difference by 2. N is number of terms upon sine difference by 2 into sine of first angle plus last angle divided by 2. First angle and the last angle, you will have the last term, sky angle. Last angle divided by 2. This is the sum. If you have cos series, cos A plus D, same thing, except यहाँ पे cos हो गया. This is still n terms. N terms. So again, if you have cosine series in which the angles are in AP, then this is, what is the sum of this series? This is again sine n into difference by 2, sine difference by 2. Up it will become cos of first angle plus last angle by 2. So this is the series formula which you must remember for solving many questions of trigonometric series, right? So now, how can I use this? You can see all the angles are in AP here. If all the angles are in AP, you can see what is this? This is sine n. N is number of terms. So how many terms we have? 6 terms. N into difference by 2. What is the difference of angle? You can see difference of angle is 2 pi by. D is 2 pi by 7. By 2, that is pi by 7. So this is sine n into difference by 2 upon sine difference by 2. Common difference of angles. Into sine of first angle plus last angle. Now you can see what is first angle plus last angle. First angle is 2 pi by 7. Last angle is 12 pi by 7. So 14 pi by 7. That is 2 pi by 2. I hope this is clear. First angle plus last angle by 2. So what is first angle plus last angle? 14 pi by 7, which is 2 pi by 2 by 2. This formula. Okay. Minus iota. Now again, we can apply the same thing. Same series except we have cos here. Same series except we have cos here. So it will be same sine 6 pi by 7. Sine n into difference upon 2. Sine difference upon 2. Now here this will become cos of first angle plus last angle by 2. Now see, we have to just simplify this. You can see this is sine pi and sine pi is 0. So we know I can cancel this. So what is this term now? You can see here again, this is cos pi. Cos pi is minus 1. So this will become, this is minus 1. So this will become iota. Minus plus. You can see here, if I take these two are supplementary angle. If this is theta, this is pi minus theta. This is theta, this is pi minus theta. And if these are supplementary angles, both the values will be equal. You can see this is theta, this is pi minus theta. Sin pi minus theta is same as sin theta. That will be cancelled. So what is the answer? This is equal to iota. So this sum is equal to iota. This sum is equal to iota. So I hope this is clear. What we have done is we have just used the trigonometric. We have not used complex numbers for solving this question. But if I want to solve this question by using proper complex numbers, only by using complex number, then how can you use this? तो वो भी हम यहाँ पे देखेंगे. So let's move to the next Let me take the next page. Okay, just hold down. So we have this question, sine 2k pi by 7. Okay, let me write. Just hold. This is sine 2k pi by 7 minus iota cos 2k pi by 7. And we have to find the summation of this 2k pi by 7. Summation k is equal to 1 to 6. Okay. So this is how can you solve this question? You can see here. If you just see here, can I say this is k is equal to 1 to 6? If I take minus iota common, or otherwise what you can do is you can just multiply with iota. So if I multiply with iota, this will become iota sine 2k pi by 7. Iota से multiply किया है तो divide भी करना पड़ेगा, ठीक है? तो I have just divided by iota. 2k pi by 7 iota, and this iota square will become minus 1, so this will become plus cos 2k pi by 7. So we have this expression. Now, can we say this is equal to, what is 1 by iota? 1 by iota is minus iota. So this is, I'm writing this is minus iota, 1 by iota minus iota. This is k equal to 1 to 6. And this is e raised to iota 2k pi by 7. We have this expression, correct? Cos theta plus iota sin theta is e raised to iota theta, so which we have written. So basically what we have this expression is, if I take, let's say if I take alpha is equal to e raised to iota 2 pi by 7. Let's say if I take e raised to iota 2 pi by 7, this is sigma k is equal to 1 to 6. And this is alpha raised to k. E raised to iota 2 pi by 7, I have taken alpha. So what is this expression? This is minus iota. Alpha, alpha square, alpha cube, so on, alpha raised to 6. We have this expression, correct? Now, understand this. If you have alpha is equal to e raised to iota 2 pi by 7, what are the seventh root of unity? What are the seventh root of unity? Can we say seventh root of unity will be 1 alpha, alpha square, alpha cube, alpha 4, alpha 5, alpha 6, where alpha is e raised to iota 2 pi by 7. This अभी जो हमने concept discuss किया था, e raised 1 raised to 1 by n. Nth root of unity, 1 alpha alpha square alpha raised to n minus 1, where alpha is e raised to iota 2 pi by n. n का वैल्यू हमने कहा है 7 because we are writing seventh root of unity. Now see, ये वही तो है. What is this? Alpha alpha square alpha 6. These are the seventh root of unity except 1. इसमें 1 missing है. Correct? Now see, we know the property of nth roots of unity, that sum of nth roots of unity is always equal to 0. That is 1 plus alpha square, so on, alpha raised to 6 is equal to 0. Sum of nth roots of unity is 0. So this sum is equal to 0. So what is this value? Can we say this is equal to minus iota minus 1? Why minus 1? Because the sum 1 to 1 alpha raised to 6 is equal to 0. So this will become minus 1, minus minus plus. So what is the answer? This is equal to. So I hope this is clear. How can you solve this question using complex number? In the previous method we discussed how can you use this question, how can you use trigonometry to solve this question, series question. Okay, this is pure complex number method. Okay, so I think this finishes your complex number revision. So I hope you have understood all the questions which we have discussed. Okay, so in the next video I'll take the next chapter. Please do subscribe to this channel so that you get the notification when we upload a new video on the next chapter. And if you have any suggestion or any topic which you want me to discuss, please you can comment in the comment section. Okay, so that's it for now. Thank you.